Okay, in this video, I'm going to talk about some more things that you probably already know, you just might not know the names for them. So first, let's talk about identities. This is really easy. Easy stuff here. The additive identity is 0, and the multiplicative identity is 1. Alright, what is an identity exactly? The identity of an operation does not change the number in the operation. So 0 is the identity for addition because adding 0 to a number doesn't change it. We can say 7 plus 0 is still 7, negative 15 plus 0 is still negative 15. Nothing changes. Similarly, 1 is the identity for multiplication because multiplying a number by 1 doesn't change it either. Right? We've got 5 times 1 is still 5, 0 times 1 is still 0. But of course 0 isn't an identity for multiplication because multiplying by 0 does change it. So 0 is the identity for addition because 5 plus 0 is still 5. But it can't be an identity for multiplication because 5 times 0 is not 5, it's 0. So 0 is actually the only identity for addition, and 1 is the only identity for multiplication. Okay, so that's really easy. Let's talk about the inverse now. The additive inverse of a number is the opposite of that number. So if the number is a, its additive inverse is negative a, because if we take a and add negative a to it, we're going to get 0. The multiplicative inverse of a number, such as a, is going to be 1 over a, assuming a does not equal 0. Because if we take a and multiply it by 1 over a, we're going to get 1. So a way to think about an inverse is that an inverse is whatever number will give you the identity of a certain operation. So the additive inverse should give you 0 when you add, and the multiplicative inverse should give you 1 when you multiply. For example, if you start with 5, the additive inverse is negative 5, because you can add 5 to negative 5 and get 0, which is the identity for addition. The multiplicative inverse is 1/5, because you can multiply 5 by 1/5 and get 1, which is the identity for multiplication. So this stuff's really easy. You already know that a times 1 over a is going to be 1. You already know that a minus a is 0. You know this stuff. It's just the names that we're using for it is a little bit something that you might not be used to. But what I really want to talk about in this video is the zero product property. It's something that will be really helpful, especially later in algebra, and you'll find out more about it then. But just for now, if we have two numbers, a and b, and a times b is 0, then either a is 0 or b is 0. Or both, of course. 0 times 0 is also 0, right? But if two numbers are multiplied together to get 0, one of them has to be 0. That's the important thing. Another way to say this is that if a is not 0, then b has to be 0 for this to be true. If b is not 0, then a has to be 0 for this to be true. And you can kind of see this, you can kind of understand it intuitively, but let me just prove it for a minute, just so there's no shadow of a doubt that this property is true. And the reason I want to prove it so carefully is because you're going to be using it a lot later on in algebra. Okay, so what I said was that if a is not 0, then b has to equal 0. Well, I have ab equals 0, and let's just assume a is not 0, because what we're trying to prove is that if a isn't 0, b has to equal 0. Let's just divide both sides by a, and we can do that since we've assumed a is not 0. And what do we get? This cancels. 0 over a is 0, so we get b equals 0. Now let's assume that b is not 0. So we've got ab equals 0. And now we can divide both sides by b. 0 over b, ab over b, b over b is 1. So we've got a equals 0 over b is 0, so a equals 0. Alright, so we've just proven that if a is not 0, b has to equal 0. And if b is not 0, a has to equal 0. That's the zero product property. If a times b is equal to 0, then either a has to equal 0 or b has to equal 0, or both. That works too. Thanks.